Hello, this is John Purcell from quantumlifetime.com, and in this tutorial we're going to talk a bit about energy, because I think unless we look at the absolute basics of physics, when we look at the more peculiar quantum stuff, I'm certainly going to get lost, and you may do too. So let's go right back to the beginning here, and before we start talking about light intensity and that kind of thing, let's talk about energy a bit. So energy is a concept that was around a long time before physics adopted it. So when New Age people talk about the room having a good energy and so on, they were kind of there first, and physicists came along and adopted energy into physics. And in fact, energy has a strict definition in physics. There's nothing woolly about it in physics. It's a particular quantity of stuff, and this is how we define it. Let's imagine that let's imagine we can measure some distance along here. So let's say this is position 0 and this is position X. It could be 15 meters or whatever you like. And then imagine that we have a particle or some solid object here, and we start pushing on it, and we push on it with a force equal to F, and force is measured in newtons, but just imagine it's a constant push basically. What will happen is the thing will start moving, and it will move faster and faster. If we keep pushing on it with the same force, it will accelerate at a constant rate. And in fact, Newton's second law tells us that the force applied in appropriate units is equal to the mass times the acceleration. So for a given force we'll get a given acceleration, and for heavier things they're going to accelerate more slowly, and lighter things are going to accelerate faster for the same force. Or if you see a thing moving, accelerating at a particular rate, it's getting faster and faster with a particular rate, then if it's very light you can infer that there's only a light force pushing it, and if it's very heavy you can infer there's a big force pushing it. So that's Newton's second law, and this thing's going to get faster and faster at a rate which depends on its mass. So it might start off at 0 at a speed of 0, and let's say after a second it has a speed of maybe 5 meters per second, and at another second it's got a speed of 10 meters per second, and then 15 meters per second after 3 seconds. So its acceleration in that case would be 5 meters per second per second. 5 meters per second, that's a measure of acceleration. And when it gets to here, it's going to have a final speed v, let's say. And we're going to take a bit more of a look at this setup in the next tutorial. But what I want to note here is that we say that there's this notion of work done, like the kind of work that you had to do in accelerating this up to this speed over this distance, or pushing on it for this amount of time. And we define that by saying that the work done here is equal to the force you had to apply to this thing, assuming it's a constant force, times the distance travelled. So often force is denoted by S, but here we've written X, so I'll write Fx. So the work, that's the definition of this abstract quantity called work, is the force applied times the distance that it was applied for. And in fact, energy is the stored ability to do work, or you could also think of it as being the work done is the amount of energy that has changed form. So when we finished here, we've expended an amount of energy equal to force times the distance. And this thing now contains what we call kinetic energy, because it's moving. We see it as having energy, and that energy is quantitatively equal to the force times the distance that it was accelerated through. And that's a strict definition of energy. And if you use appropriate units like meters, seconds, joules for energy, I said seconds, okay, then you don't have to use any like conversion constants. Everything works out neatly like this. If you use the SI system, it's called meters, seconds, newtons, joules, all that kind of thing. So in the next tutorial we're going to look at another definition for energy, which is going to follow from this. situation here. So join me again then, and until next time, keep it real.